the path y equal to 0. So it's going to be a limit of x and y tends to the origin of a sine of an xy divided by x squared. Here I'm putting y equal to 0, and in this case you will have sine over 0 divided by x squared, which means 0. So the limit through y equal to 0 is going to be 0. Now, what if I use y equal to x squared? Y equal to x. In this case, the limit of x, y tends to the origin will be a sine of x squared by x squared, which is the famous and the classical problem that we already had previously, which is gonna lead to positive 1. As you can see, the two limits doesn't equal to each other, which means this limit doesn't exist, and that's what we did go through in the previous lecture. Okay, that if you are having studying the limit of xy tending to a certain point using more than one direction and they have different values, then the function doesn't exist. Of course, I can't use here x equal to 0. Yani I can't use the y-axis as a path of approaching this xy into the origin. I can't do that. Why I can't do that? لأنه x equal to 0, it's already forbidden from the definition of this function. It's not going to be defined. Okay, so this is why we eliminated using the y-axis. So we can use only the y equal to 0 for this function, which is going to limit to a 0. And also if we used y equal to x, the two limits is not equal to each other, and so the limit doesn't exist for this one. That's another problem. I will solve it with the definition. I did exactly as we used to do. This is the function minus 0. So I will try to simplify. This is going to be x squared. That's going to be the root of x squared plus y squared. Now I have cosine of x squared plus y squared, which is for sure less than or equal to 1. X squared, I can replace it by x squared plus y squared. I can eliminate these two guys, so now I have root x squared y squared, which is less than epsilon. That means delta is less than epsilon. That's the relation connecting them. Now I have the relation between both of them, that delta is equal to epsilon, as I told you, and the proof is given. Those exercises I want you to try in home by yourself. They are exactly like the ones that we solved together, and we already solved this problem and solved that problem previously, so it's going to be easy on you. Thank you very much for today, and inshallah I will continue next time with the continuity part in this discussion. Thank you very much. I hope you understood or strengthened the information that we took yesterday. Thank you, and I will see you tomorrow, inshallah. Thank you very much. Bye-bye.